It's a pleasure to be here, and it's easier for you to hear me if I press the right button. I guess it's my job to try to wake everybody up following their lovely lunch, so I will attempt to do that. The automotive industry has a long and proud history of introducing innovation. And right back to the introduction of the assembly line by Henry Ford, we've seen massive reductions in the time taken to make components and to make cars. And Ford weren't the only ones, and these two examples aren't the only examples of innovation in the industry. But there's one area that has very largely eluded automation until today, and that's making wiring harnesses. These tend to be assembled largely manually. They're expensive and they're labor intensive, and as a result, there's a high degree of error, with the result that pretty much everything has to be 100% tested. And another result of that is long and complex supply chains. It's not unusual to find cars being assembled in Northern Europe and their wire harnesses coming from Northern Africa. A lot of attempts have been made to automate the process, and you can look back in the patent histories for over 40 years now of different attempts to automate the process of assembling a wire harness. But most of them have focused on doing the tasks that humans do using a robot. And that's a little bit like trying to use a humanoid robot to wash the dishes. It's not logical. You wouldn't do it, you'd use a dishwasher. What we've done at Q5D is harness various techniques that have come about as a result of additive manufacturing. Advanced CAD/CAM that allows us to plan the toolpath of robots and ease the programming of them, because historically a robot can be only programmed to do one task. By changing that, by harnessing the opportunities of new technology, and in due course the opportunities that AI will present us to ease the design as well, we're able to apply wires, standard automotive wires, to just about any surface. That complex 3D structure that makes up the internal of most components can now be wired autonomously. And just going into a bit more detail about that, the process generally starts with a three-dimensional drawing of the component. We can do an overlay of the tool paths that are then required in order to build that component and to lay the wiring on top of it. So imagine being able to take a drawing of a component, the wire list that you want to put, so the functions you want to put onto it, and then be able to just have that produced by a machine. And because it's a machine and because it can be flexibly programmed, that machine can make many different products, many different variations of the same product with but a small change to the drawing. So our hardware in this instance is a series of interchangeable tools that can sit on a number of different sized robotic cells, so we can cater for a large number of different products. And each of them, in its own way, can manufacture, autonomously assemble wiring harnesses. This gives a lot of different design possibilities that haven't been entirely feasible until now. So wires that are secured directly to surfaces. And I'll come back to that in a moment or two with a case study. Making a flexible wire harness. So a lot of wire harnesses today are separate components in their own right. That can still be the case with this approach. You can make semi-rigid wiring harnesses that are in laminates for protection from the environment, or lay uninsulated and insulated wires onto a surface. Imagine being able to wire the internal surface of an instrument panel entirely without being touched by hand. And finally, and perhaps I think for the future most interestingly, there's the opportunity for designers to combine more than one technique, multiple techniques, to make products that perhaps today are either made on a series of different processes or we haven't even thought of yet. Our machines are designed for high or low volume. A single machine can make lots of different products, or we can put together the machines in such a way that they can work collaboratively with each other so that they can achieve higher volumes. Depending on the size, we can build a machine anything up to take a component 2.5 meters by 1.5 meters. So think something that was the headlining of a car or the lid of a battery box. I wanted to just give you an idea of one of the many applications we're currently looking at, and that's the headliner of a car. It's a highly visible area. It's very difficult to assemble. If you have a rattle in it, it usually causes a customer complaint very quickly. And on a lot of vehicles now, it's also an area where an awful lot of sensors, antennas, and other functions have to sit. And the result of that is a very, very complex set of requirements in one of the most sensitive areas of the car, where there's also, particularly if you have a sunroof, as many cars do, very tight for space. So automation in this instance can help in a couple of ways. Because we can use a machine to directly attach the wires straight to the substrate, in this case a headliner, we don't need all the tape wraps and the foam and the clips and the other items that traditionally go into making that particular component. None of that is necessary because we adhere the wires directly to the surface of the component. And because we can stack the wires in pretty much any shape we like and build in layers pretty much anything that you want, avoiding all the other components that are within the headliner, there's a great deal more flexibility available to the designer to fit in yet more functions. And when we look at, we were seeing this morning about the direction of cars, the increase in autonomous driving, etc. All of that requires more sensors, things that will pick up on movement of individuals. And then once our cars are driving themselves, the probability is that we're going to be wanting to be entertained in other ways. So entertainment within the vehicle is likely to have a massive change as well, all of which is going to require yet more sensors, yet more modules, yet more microphones, yet more speakers within the car. So it isn't just about saving labor, although automation will, and it often does. It's also about being able to shorten those supply chains, being able to eliminate materials, being able to plan much more accurately. So at the moment, it's not uncommon to have a situation where you might only know what car you're going to build next on the line with about 3 hours' notice. But you will have had to have ordered the wiring harness for that car 30 days before. And that means there's a lot of inventory cost tied up in the automotive industry. There's also a lot of cost tied up in spare parts. Spare parts typically are manufactured at the same time as the model year, and that means you're then storing them for anything up to 10 to 15 years. These are all costs that we can seek to address through automation. And finally, because we're also changing the way that we make these parts, we can address some of the weight issues as well. So a lot of wiring harnesses, the wires within them are actually sized to deal with the mechanical stresses that they may experience whilst being manually assembled. If you're not manually assembling, if you can use a machine that cannot overstretch or overstrain the wires, then you don't need quite such strong wires, which means there's some more saving both in terms of materials and perhaps more importantly in an EV, weight. So when we look at how is this progressing, studies that we've done so far, for a component that currently would cost you around about £18 to have made, we're projecting that within a couple of years, we will be making that part for less than 50% of that cost. And some of that is going to be driven by our technological movement, and some of that is going to be driven by the designers of products being able to come up with different ways to do things. We're working with a number of industry groups to bring about connectors that can speed things up as well and provide a step change. The issue with connectors is they're largely developed for people to assemble, and whilst our machine can do that, we can have a much higher speed if we can redesign those connectors. So I'll leave you with the thought that maybe we're seeing the next automation revolution, taking advanced CAD/CAM designed for 5-axis additive manufacturing, high accuracy robotics. Our robots are accurate to within plus or minus 30 microns. Taking the existing materials the industry is used to using, the same wires, the same glues, the same polymers, applying them in a completely different manner and in a different order, and saving time, labor, and materials. Thank you.